That we know that is the axes are called x-axis, y-axis, and z-axis, right? X-axis, y-axis, and z-axis, right? So here also the first exercise which is belongs to directional ratios, directional cosines. Whatever we studied in vector concept, based on that we'll do the first exercise, right? Here I'm taking this is x-axis, this is y-axis, this is z-axis. Clear? These are the three mutually perpendicular lines: x-axis, y-axis, z-axis. There are three types of planes we having. Three planes are determined by the pair of axes, like this is called here, this is called xy plane. This plane is belongs to x and y axis. This is yz plane. This is xz plane. Okay. So here three planes are there: x, y, yz, and zx, and three coordinates plane divided into like how many equal parts? Like how many octants? How many octants we can divide? So we can divide the space into 8 parts, known as octant. 8 parts, right? So, and also here, we know that the point on the x-axis, any point on the x-axis, we can take any point that can be given by x 0 0, and any point on the y-axis is 0 comma y comma 0, and any point on the z-axis is 0 0 z. Am I right? Okay. So, like every point in the space in three-dimensional, we can write in the form of triplet. We can write as a triplet in the form of like x comma y comma z, x comma y comma z. Every point in the space, okay, we can write always in the form of x, y, z. This is called a three-dimensional geometry, right? And also already you studied the distance between 2 points in class 11th, like when they have given two different points. Let us take this point is uh, this point is x1 y1 z1. This point is x2 y2 z2, x2 y2 z2, and the distance from the one point to another point that
Sir, could you
the
scroll up one line?
okay, the distance between these 2 points is x2 minus x1 the whole square plus y2 minus y1 the whole square. Here we are having a third variable also, that is z2 minus z1 the whole square. This is the distance between uh, 2 points. And if you want to point any point on the line segment joining A and B, like you take this is capital A, this is capital B, distance between A, B is okay. This is the distance formula, very easy. I want to find another point C. Another point C, the point C can divide, the point C can divide the line segment AB in the ratio of m is to n, m is to n. Then your C point C is clearly equal to like same formula mx2 plus nx1 by m plus n. This is internally. So my2 plus ny1 by m plus n. The same way mz2 plus nz1 by m plus n. Okay. So this is internally. If it is externally, the point, like I want to find the point C is external point. If it is C is externally point, so that we know very well, we should take minus, minus, minus. Instead of plus, you can take minus, 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 minus. That is mx2 minus nx1 by m plus n. This is about internally and externally, and also clearly we know that any point exactly midpoint of AB. I want to find the midpoint of any two different points. Okay, let us take this is A, this is B. Yes, C is the midpoint. What is the midpoint formula? X1 plus X2 by 2, Y1 plus Y2 by 2 plus Z1 plus Z2 by 2. Is that clear, students? So when the x is
Could you scroll one line up that formula? Yeah.
yeah, x1 y1 z1, this is x2 y2 z2. Okay, the point midpoint is given by clearly. This midpoint is clearly equal to x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. This is clearly the point C, midpoint formula. Okay, students? And also you studied centroid of the triangle when they have given three vertices of the triangle in three-dimensional. Okay, whose vertices are x1, y1, z1, and x2, y2, z2, and x3, y3, z3. Okay, A, B, C. Centroid clearly the point of intersection of medians, the point of intersection of medians, and the centroid can be denoted by G, capital G. Okay, so if it is x1, y1, z1, and x2, y2, z2, and x3, y3, z3, right? Then centroid G is equal to x1 plus x2 plus x2, x1 plus x2 plus x3 by 3, and y1 plus y2 plus y3 by 3, comma z1 plus uh, z1 plus z2 plus z3 by 3. This is the concept you studied in class 11th. Okay, but in this class 12th, mostly each and every problem is depending on the direction ratios and direction cosines. Direction ratios, direction cosine. Without direction ratios, without direction cosine, there is no any problem, right? Every problem mostly which is depending on the direction ratios, direction line, direction cosines. Right. So what we are going to study in class 12? What are the concept we are having in 3D in class 12? Okay, mainly three concepts we are having. The first one is direction.
Sure. Could you scroll? Show the triangle.
Okay, direction ratios.
Sure. G is the midpoint. Is the coordinates of the
No,
midpoint.
G is called the centroid. Centroid nothing but. So first we have to take the midpoint of the triangles, like this is the midpoint of BC, I'm taking as E, midpoint of AC I'm taking as F, this I'm taking midpoint of AB is some D. D, E, F are the midpoint, so we can join all these midpoints from the opposite vertex. So this is the vertex. From this vertex to E, I have drawn that this is called medians. I joining this B and F, then C to D. You can join these here. We get a common point to all three. This is called median. AE, BF, and CD. These are called medians. All medians are intersecting at one point. That point is called centroid. Centroid formula is this is the centroid formula, right? And direction cosines. Okay, this is the first important concept. And the second important concept we are going to discuss about line. Equation of line in vector form in Cartesian form. And the third one is plane. The third concept is plane concept. Planes concept. Plane equation of plane again we are going to discuss in vector form and in Cartesian form. So here coming to the Cartesian form, the plane equation is ax plus by plus cz plus d is equal to 0. So don't confuse in student. Generally the line equation in 2D will write ax plus by plus c is equal to 0. But in three-dimensional ax plus by plus cz plus d is equal to 0 will give the equation of plane, not equation of line. Okay, this is the equation of line in 2D, but coming to the 3D, ax plus by plus cz plus t will give equation of plane. I can explain you why we should get like ax plus by. So what is the equation of line in Cartesian form? Equation of line same x minus x1 by when they given 2 points x2 minus x1. We already studied y minus y1 by y2 minus y1. But in three dimensional, we are going to get another point z minus z1 by z2 minus z1. So this is the equation of line in three dimensional. Okay, just this is about just I have written only Cartesian form, only Cartesian form. After that, I'm going to write the equation of line and plane in vector form also. So after explaining the concept of line,
Does that formula x minus x1 by x2 minus x1, does that give the slope of the line?
it is not a slope of the line. If the slope of the line is what y2 minus y1 by x2 minus x1. Like generally, if you take x minus x1 by x2 minus x1 is equal to y minus 1, this is 2 point form. The line equation in 2 point form. Here also same, this is the line equation in 2 point form. It's not a slope intercept, slope point form. Okay, line equation in 2 point form. First, this is the concept we're having, and in the concept, like we are going to find the angle between two lines, angle between two planes, angle between line and plane. Angle between two lines, angle between two planes, angle between line and plane. We don't have this here in NCRT. They deleted. Okay. Okay, let us start the concept of direction ratios, direction cosines. Since already we know that about direction ratios, I already explained. Once again, those are absent for the class. Let us take x-axis and the y-axis and the z-axis. Okay, clearly here this is x, this is y, this is z. See, three-dimensional concept is interesting only and also very easy. Like, okay, I'm going to take any line in the space. Okay, any line in the space. Okay, students. Any line, I'm going to take the line in the three-dimensional. This is the line. So this line can make an angle. Just a minute. Right. So I'm going to take any point. This is p of x comma y comma z, any point in the space, and I'm joining origin and the point P. That we know that with respect to x-axis, the line can make an angle alpha. And with respect to y, beta. With respect to z, it can make a gamma. So already we studied the then cos alpha, cos beta, cos gamma are called direction cosines, can be denoted by L, M, N. Okay, and the direction ratios means any vector, you can take any vector, A is any vector like A1I plus B1J plus C1K.
Sure. Is gamma the angle between z and x?
Sorry,
Gamma is the angle in the x z.
Z and the given line. OP be the given line, O is the starting point, and P be the ending point. So the gamma is angle between z-axis and the line OP, line segment OP. Okay, not angle between x and z. So L, M, N are direction cosines. Here A1, B1, C1 is called direction ratios. And remember students, direction cosines and direction ratios always proportional. Always proportional. Like see here, A is equal to A is the direction when I consider A comma B. Generally, see in three-dimensional geometry, in any question, the direction ratios can be denoted by small a, b, c. Direction cosines can be denoted by L, M, N. Direction cosines always L, M, N. Direction ratios can be denoted by small a, b, c. Then direction cosines and direction ratios always proportional. Like see here, we can write L is equal to L is equal to or else A is equal to LR, B is equal to MR, and C is equal to NR. See here, A by L is equal to R, and B by M is equal to C by N. So I am equating A by L and A are proportional, B and M are proportional, C and N are proportional to each other. So that remember simply the direction ratios, direction cosines always proportional to each other. Proportional. See, mainly if they give a line segment and joining 2 points, like 2 points, let us take this is A of x1, y1, z1, and B be any other point x2, y2, z2. So A comma B are any 2 points of the given line segment. Then I want to find the direction ratios with help of given 2 points. Okay, this type kind of questions are there in exercise 1, very easy. The direction cosines. So direction cosine, so first direction ratios. Direction ratios, when they have given 2 points, the direction ratios is given by simple x2 minus x1 comma y2 minus y1. As we studied, I already explained this concept, z2 minus z1. So this will give the direction ratios. So then after I want to find the distance between A to P. What is the distance from the point A to P? The distance, sorry, A to B. AB distance. AB distance is equal to root over x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So directly the direction ratios are here x2 minus x1, y2 minus y1, z2 minus z1. Then the direction cosines is given by the direction cosines of AB line segment is equal to simple students. See direction cosines, direction ratios are x2 minus x1 by the distance from A to B, AB. Y2 minus y1 by AB. So you should find the distance from A to B. Then after the direction ratios by the distance from A to B is given by direction cosines. AB. AB means the distance from the point A to B. So these are the condition for finding direction ratios and direction cosines. Very simple direction ratios for the given 2 points is x2 minus x1, y2 minus y1, z2 minus z1. Direction cosines is direction ratios by the distance from A to B. Okay, let us see here. So first I am explaining the concept easiest method. After that I am going to explain very briefly, right? See here, for example, first the name of the arctant. Okay. This is like 12.1. 12.1 very easy. 12.1 is easy, and I'll explain the concept of. I think so. That is about Class 11th exercise, that one. Okay, this is about class 12th. Right, students. First one, the answer is, when you see that, if a line can make an angle 90, 135, 45, nothing but this is alpha, this is beta, this is gamma with x, y, z axis respectively, find its direction cosines. Find its direction cosines. Is that difficult? What are the direction cosines? L is equal to cos alpha, M is equal to cos beta, L is equal to cos gamma. Got it? Yes, substitute alpha beta value. Alpha is 90, then L value is,
If L, M, and N are direct cosines, then what's A, B, and C?
sorry, ABC are
Just
direction ratios. ABC are called direction ratios. Here L, M, N are called direction cosines, right? So already they have given the angle. So x-axis, y-axis, z-axis, there is a line. The line can make 90 degrees with x-axis and with y-axis 135 degrees, with the z-axis 45 degrees. So that we need to find direction cosine. So now substitute this value and tell me the answer. What is the answers? L is equal to cos 90, 0. And M is equal to cos 135. What is the cos 135 students? Cos 135
minus 1 by root 2.
minus 1 by root 2. N value is plus 1 by root 2. So after getting the direction ratios, how can you check whether your answer is correct or not? So if you want to check your answer whether it is correct or not, simply you have to check L square plus M square plus N square is equal to 1 or not. Okay, the sum of the squares of direction cosines always is equal to 1. Check this condition. Yeah, it is clearly equal. Right? Fine. That is the first question. Coming to the second question. Find the direction cosines of a line which makes an equal angles with the coordinate axis. Equal angles means alpha should be
45,
equal
40.
to beta should be equal to gamma. When alpha is equal to beta is equal to gamma, then what about the direction cosines L, M, N values? L is equal to, for example, cos alpha is equal to cos beta is equal to cos gamma. Nothing but when I take alpha is equal to beta is equal to gamma, then cos alpha is equal to cos beta is equal to cos gamma always. Okay, yes or no, students? When I take here, all three angles are equal. So alpha is equal to beta is equal to gamma. Then cos alpha is equal to cos beta is equal to cos gamma. Right? This cos alpha nothing but, since we know that this is L, this is M, this is N. Since we know that L square plus M square plus N square always is equal to 1. Yes or no? Always it is equal to 1. Now we can substitute that value. What is L? Cos square alpha. What is M? Cos square uh, beta. Cos square beta plus cos square gamma is equal to 1. Since we know that cos alpha is equal to cos beta, so that cos beta also I written cos alpha only. Cos gamma also equal to cos alpha is equal to 1. So 3 cos square alpha is equal to 1. Then cos square alpha is equal to 1 by 3. Then cos alpha value is plus or minus 1 by root 3. So therefore, the direction cosines are L is equal to plus or minus 1 by root 3 and M is equal to plus or minus 1 by root 3 and N is equal to plus or minus 1 by root 3. Okay, L having two values, M having two values, N having two values. Students, remember that you don't think that L, M, N are unique. L always having two values, M always having two values. Why? Because of the reason. See, when you take a line here, there is the line segment. When you take a line segment here, any line segment, like this is the point P of x comma y comma z. Okay, if I take Okay, I want to extend the same line in like here. This is also the same line. I extend in opposite direction to the, this is the point I'm taking as like Q. See here, with respect to x-axis and alpha, and angle is alpha. Then with respect to x-axis, so what about other angle, other side? This is one side, O to P. What about O to Q? What is another angle with respect to 180 minus alpha? The same line with respect to x-axis, it can make an angle positive direction. A total is 180. From other side, it will make an 180 minus alpha. So actually what I have written here, so in the same way with respect to y-axis, it can make an angle beta, and with respect to y-axis, other side is 180 minus beta. In the same way with respect to z-axis, gamma 180 minus gamma. So actually the direction cosines always is given by L is equal to cos alpha as well as L is equal to cos of 180 minus alpha. We are going to get two direction cosines. One is positive direction, one is opposite direction, in other direction. But mostly we can take the angle is acute angle, so that like we'll take like cos alpha, cos beta, cos gamma only. Okay, 2 plus or minus 180 cos 180 minus alpha is minus cos alpha. From these two, see here L is equal to plus or minus cos alpha. Is it okay? L having two values, one is plus and minus. So that here in above one, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. So this is the answer. Having any doubts, friends? I think so, no doubt. Equal angle means that is also easy. Right. Fine. See, a line has direction ratios. Direction ratios. I clearly told you that direction ratios always denoted by small a, small b, small c. Direction ratios always denoted by small a, b, c. Direction cosines are L, M, N. Okay, here direction ratios are given. We want to find the direction cosines. Okay, we need to find the direction cosines. How can you find the direction cosines? Very simple, students. It's very simple. See here, when they have given direction ratios are A, B, C. I want to find the direction cosines. Then the direction DCs. The direction cosines are denoted by L, M, N. So with alpha of the direction ratios, if you want to find the direction cosines, though, so L is given by A by root over A square plus B square plus C square. M is equal to B by L, M, N. B by same root over A square plus B square plus C square. And N is equal to C by root over A square plus B square plus C square. That's it. Very simple, right? So in the given question, your A value is minus 18, 12, minus 4. Minus 18, B is equal to 12, C is equal to minus 4. I think it's, yeah, minus 4. Now, is it difficult to find the direction cosines? No. So direction cosines are minus 18 by 12, minus 18 by minus 18 square at 12 square plus minus 4 square. This is equal to minus 18 by root over 18 square. What is the 18 square value, students?
324.
324 plus 144 plus 16 is equal to how much? 160 plus 324.
484.
480. Root 484 value. Any value?
22.
So minus, so finally this is minus 18 by 22. Minus 18 by 22. In the same way, you have to find m value with help of b value. So L is equal to minus 18 by 22. So 22 is fixed for all the direction cosines. Denominator is fixed because m value is equal to uh, b by like b by means 12 by root over same value, that is equal to 12 by 22 will get. In the same way, n is equal to c by minus 4 by 22. But in exam, in every case, like m is equal to, you should write 12 by minus 18 square plus 12 square minus 4 square. So like that, you must be right all the steps properly, right? So again, if you get any doubts, if you want to check whether your answer is correct or not, again same L square plus M square plus N square. You should check that whether it is equal to 1 or not. So it is, obviously it is equal to 1. So when they have given ratios, we can find the direction cosines like that. Mostly they ask the question like direction ratios only they'll give, they ask you to find the direction cosines. But you may get doubts. Okay, sir, direction ratios are given, we can find the direction cosine with help of this condition. Then when they have given the direction cosines, then how can you find the direction ratios? 99% they won't ask that question, that kind of question. In case if they ask, I'll tell you the procedure, no doubt, right? This is about when the direction uh, ratios are given to find the direction cosines. Any doubts here? Any doubts? Okay. Coming to the next question. See here. Here, uh, show that the points 2, 3, 4, and -1, -2, 1, and 5, 8, 7 are collinear. Are collinear. Okay. So how can we check that these 3 points are collinear? There are 3 to 4 different ways we're having to check whether the 3 points are collinear or not. Let us take this is first point is A, second point is B, third point is C. We know that AB plus BC is equal to AC. This is the one procedure. Okay, one procedure. And area of the triangle is equal to 0. That is the second procedure. Okay, and third vector, we need to find the vector AB, and you have to find the vector BC, and we have to show that AB is equal to lambda times of BC. Lambda times of BC. Okay, nothing but these two are parallel, or else AC is equal to AC vector is equal to lambda times of AB plus mu times of BC. Then we can say that ABC are collinear. Okay, we don't want about all these things. These are again like a by confusing process. So how to check the given 3 points are collinear with help of the direction ratios? It is very easy to check whether the 3 points are collinear or not. Collinear or not with help of the direction ratios. I told you very clearly when they have given the 2 different points, then to uh, check that to find the direction uh, ratios and direction cosines. Okay, when they have given 2 different points, how can you find the direction ratios here? X2 minus x1, y2 minus y1, z2 minus z1. That's it. This condition I'm going to use now. Okay, what are the given 3 different points here in the question? One is, I'm taking A is 1 point, let us take A is equal to 2, 3, 4. 2 comma 3 comma 4, and B is equal to another point is -1 -2 1, -1 -2 and 1, and let us take C is equal to the third point is 5 8 7. Okay, here your wish. You can find any two direction ratios, either AB direction ratios or BC direction ratios or AC direction. Any two direction ratios I required. Okay, first I am going to find the direction ratios of AB. So before that, I want to take this is x1, y1, z1. This is x2, y2, z2. Then the direction ratios are, the condition is x2 minus x1, y2 minus y1, and z2 minus z1. Okay, this is given by, this is equal to x2 minus x1. What is x2 minus x1? x2 is minus 1, minus 1, minus 2, minus 2, minus 3, and 1 minus 4. So this is equal to minus 3, minus 5, minus 3, right? This is the direction ratios of AB, AB, direction ratios of AB. In the same way, I am going to find the direction ratios of your wish, whether we'll find AC or BC, AC or BC, any one. You no need to find all these three, just to find any two or direction ratios of any two line segment, AB or BC. Okay, let us take BC. BC or else BC means instead of BC, I want to take AC because A already we consider x1, y1, z1. This I want to take x2, y2, z2. AC. Then here again x2 minus x1, that is 5 minus 2 and 8 minus 3 and 7 minus 4. So what about the point here? 3, 5, 3. Okay, what do you observe here? What do you observe here? So when I consider the direction ratios of AB as A1, B1, C1, and this is A2, B2, C2, then we have to check whether these two direction ratios are proportional or not. Like A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to, we are getting a equal or not. It is equal to clearly a constant or not. If it is equal to, then collinear. That's all. Okay, students. I think it's already 9. Don't